Areas and volumes of similar shapes is another one of those topics that should be quite straightforward, but because of our intuition, because we want the answer to be a certain way, we often make mistakes. Now, what are similar shapes? First of all, a similar shape is a shape that's been enlarged by a constant scale factor. So if we take this rectangle here and we enlarge it by a scale factor of 2, then each side length is enlarged by a scale factor of 2. So this becomes 6, this becomes 4. So what's happened here? Well, let's have a look at our perimeter. We see here we've got 3 plus 2 plus 3 plus 2, so that's 10 centimetres, okay? And the perimeter of this one is 6 plus 4 plus 6 plus 4, so that's 20 centimetres. So we say that our length ratio is 1 to 2, which is confirmed by this doubling of lengths here. We times everything by 2 and our length ratio goes up by 2 as well. But what about our area? Well, the area of this is 3 times 2, so we get 6 centimetres squared. So you would think, therefore, that the area of this would be 12. Well, no, it's not. 6 times 4 is 24 centimetres squared, so it hasn't gone up by a scale factor of 2. In fact, our area ratio, in this case, has gone up by a scale factor of 4. Well, why is it 4? It's 4 because it's increasing by 2, but in 2 dimensions. So another way of writing this is saying it's 1 to 2 squared. So it's gone up by a scale factor of 4 because we've enlarged it by 2 in this direction and by 2 in this direction. So that's the same as enlarging it by a scale factor of 4. So my area ratio is 1 to 4 or 1 to 2 squared. Let's have a look to see what would happen with volume. Now you notice that these two cuboids, you can see they've been enlarged by a scale factor of 2. But what's happened to our volume? Well, the volume here of my original cuboid is 2 times 2 times 4. That's 12 centimetres cubed. But our volume of our second one, okay, the intuition would be to say, okay, enlarged by a scale factor of 2, so it should go up to 24. Well, no. This time 4 times 4 times 6, we get that's 96 centimetres cubed, because we've enlarged in the scale factor of 2 in 1, 2, 3 directions, which means it's actually increased by a scale factor of 8. So my volume ratio is 1 to 8. It's gone up by 8 times. And another way of thinking about this is to say it's 1 to 2 cubed, because we've increased it, we've doubled it in length in 3 different directions. Double this length, double this length, double this length, which has an effect of enlarging the volume by a scale factor of 8, or by 2 cubed. So we can draw some conclusions then, and we can say that for similar shapes with length ratio 1 to n, the ratio of the areas is 1 to n squared. So if we were to triple the length, then the area ratio would increase by a scale factor of 9, and the ratio of the volumes is 1 to n cubed. So again, if we double the length, it becomes 8. If we were to triple the length, it would become 3 cubed, which is 27. So it really goes against our intuition. So let's look at an example of these, and we've got two similar Russian dolls, and the surface area, the area around the outside of our Russian doll, is 7.2 centimetres squared, and we want to work out the surface area of the larger doll. Well, we can see that the length ratio, it's been enlarged by a scale factor of 3. So my length ratio is 1 to 3. It's gone up by a scale factor of 3. So therefore, the area ratio is a scale factor of 1 to 3 squared, which equals 1 to 9. So therefore, the surface area of the larger doll is equal to the surface area of the smaller doll, which is 7.2 centimetres squared, times that by 9. And when you do that, you should find you get 64.8 centimetres squared, because it's area. Now, if we want to work out the volume of the smaller doll, if we know the volume of the larger doll, so we know the volume of the larger doll is 145.8 centimetres cubed. Now the first thing we have to work out here is the volume ratio. Now if the area ratio is 1 to 3, the volume ratio is 1 to 3 cubed, or 1 to 27. So therefore, if we know the area, the volume, sorry, of the larger doll, to convert back to find the volume of the smaller doll, we must divide it by this value of 27. So the volume of the smaller doll is equal to the volume of the large doll, divided this time by 27 because we're working in the other direction, and we find that the volume of the smaller doll is 5.4 centimeters cubed. So be really careful with these enlarged similar shapes. Make sure you refer back to these key facts here to do with our length ratio. So find that out first, then find out the area ratio, then you can find out the volume ratio and use those accordingly. Okay.